Okay, so we're going to talk about some terminology first. So this is just important because especially as you advance in math, and especially once you get to college, there is a chance that you will have teachers that use a lot of really mathematical terminology. I do not so much. I try to use it a lot, but I also try to explain what it means when I use it. So often I'll say, for example, if I have 3x squared, I will tell you that that 3 right there is the coefficient. Coefficient is an important word to know, but I also tell you it's the big number, right, so that I can make sure you know that. So I try to use both to try to help you learn those things. But if you, have any of you ever watched Khan Academy videos and been like, feeling like it's on the same thing, but it's way over your head? That's because Khan Academy uses really precise mathematical language. They are going to refer to this expression right here as the quadratic trinomial, instead of using, simple language for it. So, yeah, so it's really important as you move forward that you understand this stuff, so whenever you're hearing about it, it makes sense with what you're hearing, right? So these will be important things for you to know that you'll talk about through the rest of your classes. But it's just really naming them. It's just really like memorizing what these names are called. So we'll be talking about polynomials today. And a polynomial is an expression with more than one term. Well, to know what that means, you need to know what a term is, right? So a term is a group of numbers and variables multiplied together. That should be a capital T right there, saying that terms are separated by plus or minus signs. So, for example, right here I've got 3x squared plus 5x minus 7. So your terms are going to be separated out by plus or minus signs. So this, so 3x squared, that would be one of your terms. 5x would be your other term, and the 7 would be your last term, right? So you would have 3 terms in this case. So they're separated out by your plus or minus signs. So a polynomial is going to have more than one term. So to name these, we are going to name them by their number of terms. So number of terms right here. And we're also going to name them by degree. And degree is their highest exponent. So these are not too difficult to remember because they use prefixes that you should already be really familiar with, right? So a monomial right here is something that only has one term. Technically, it is not a polynomial because a polynomial has more than one term, right? So this is not a polynomial. It is a monomial. If you think of mono, the prefix mono means one. It would look like this. It would not have any plus or minus signs. It might have more than one variable, but it's not going to have any plus or minus signs. A binomial, so if you're looking at that one, binomial, what does that prefix bi mean? 2. That has 2 terms, right? A trinomial, like a tricycle, right, is going to have 3 terms. And anything 4 or bigger we don't have a special name for. We would just call it a polynomial with however many terms. So if we had 7 terms, we'd just say it was a polynomial with 7 terms. Or if we had 4 terms, it'd be a polynomial with 4 terms. All right. So those are fairly simple to come up with. Monomial, mono is 1. Binomial, bi is 2. Trinomial, tri is 3. And then anything bigger than that, just polynomial with that number of terms. Your degree is going to be your highest exponent on your x. So a degree of 0 you are not going to see very often. Because a degree of 0 means there's not an x there at all. So a degree of 0 would be, for example, if you just had a constant term, just a 7 or an 8 or a 15. You will see that word right there pretty often, though, a constant. It's a number that doesn't have a variable with it. If you have a degree of 1, you're looking at your exponent, highest exponent that you see. All we see here is an x, but that means it has an exponent of 1. Those terms we call linear. Okay? The reason for that is whenever we graph them, they're going to look like a line. Okay? Here's where it gets a little bit confusing. Binomial, trinomial, monomial, that all made sense. We got linear, not too bad. If you have a degree of 2, so if your highest exponent is 2, which is what we have right here, that is called a quadratic. I think it's confusing, and I'm not really sure why they called that a quadratic, because quad means 4, and your exponent is 2. It could possibly come from the fact that squaring is different than multiplying by 2. So if you're thinking about squaring something that's different than that, but I'm not 100% sure where that comes from. You should look that up. If you have a degree of 3, we would call it a cubic. That makes sense. A cube has 3 dimensions, right? Length, width, and height. So we call that a cubic. You're looking at your highest exponent, so it doesn't matter which term it is with, right? So we would look at that 5x cubed. We don't add the exponents together or anything here. It's just the highest exponent of that term. Degree of 4 would look something like this. It's called a quartic. And then anything 5 or higher, we don't have a special name. We would just say it has a degree of 5. Okay, so let's look at naming some of these. We'll do a couple together, and I'll let you finish out these. So name each expression according to its degree and number of terms. So let's go with, let's see which one's more common. Usually we'll put degree first, and then number of terms. It doesn't necessarily have to go in that order, but that's typically what you're going to hear whenever you hear someone talk about this. So if we talk about that first one, we're looking for degree. That's the highest exponent. My highest exponent is 2. If you look at that list, Passion, if we have a degree of 2, what do we call it? Quadratic. Quadratic. So we would call this quadratic. And then, Marley, how many terms do I have on that one? 3. And so what's the name for something with 3 terms? Trinomial. So that one would be a quadratic trinomial. All right. Zane, on number 2, what is our degree? It is a 3. What's the special name for something that has a degree of 3? That is for the number of terms. Look at where it says degree. It's at the bottom of that page. Or the last slide. Cubic. So we've got cubic. And then how many terms do I have, Zane? No. Terms is just separating it out by plus or minus sign. So on that last one, the 3x squared, that's 1 term. The 7x is the second term. The 3 is the last term. So I've got 3 terms on that. So it's going to be the number of terms that you have separated out by plus or minus signs. How many do we have here? I don't see any plus or minus signs. If you don't have any plus or minus signs, you just have 1 term. So this is just 1. What's their special name if we only have 1 term? Monomial. Okay. Hank, what's my degree on number 3? No. It's 4. So you want to look, it doesn't matter what order these are in. A lot of times they'll be, the highest exponent will be first, but it's not always. And 4 is not quadratic, even though it seems like it should be quadratic, because quad usually means 4. What was on our list for 4th degree? Quartic. Good. So Q-U-A-R. See? And then, how many terms do we have there, Hank?
Does the X count as one? Like, does that count as one term? And then what's that term?
It's going to be a binomial. There's just two there. So, it's just the pieces that are separated out by plus or minus sign. So, like, even though you got a 7 and an X right here on that second part, it's still just one term because it's multiplied together. So, it would be a binomial. All right, Julian, help me on the next one. What's my degree on that? I've got 1,000. Right, I've got a degree of 0 because I don't have any variables at all, right? What's the special name if I have a degree of 0? Constant. And how many terms do I have? You're always going to have at least one. This one's just one. And what do I call it if I have just one term? It's going to be a monomial. So if you have a degree of 1, it's monomial. We don't use that prefix mono as often as we use bi and tri, which show up a lot. Like the monorail at Disney World has one rail there in the middle. Okay. All right. What have you got, Passion? Perfect. Say it again. Trinomial. Trinomial. Like a tricycle that has 3 wheels. Okay. Very good. You got a degree of 3. And then you also have 1, 2, 3 terms. All right, Vince, help me out on that number 6. Very good. Cubic binomial. Okay. Any questions? This is mostly just important because I want you to be able to understand if I call something a cubic monomial, what in the world am I talking about? Because it sounds like a bunch of crazy words that you may or may not understand. So if you understand what this means, that helps you follow whenever you're listening to somebody talk about this. All right, so let's talk about adding and subtracting polynomials. That's our main goal for today, is to be able to add and subtract polynomials. All right, so this is really, 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 really important, and we've talked about it before, but it's going to be even a little bit more difficult today. You can only add or subtract like terms. We've talked about this before when we were solving equations, because if you had a 2x, you couldn't subtract 5 from it because the 5 did not have an x with it, right? They were not like terms. So, like terms must have same variable and exponents on those variables. So, this means that x and x squared, are they going to be like terms? They are not, because they don't have the same exponents. So, your variable parts, including the exponents, have to be exactly the same. These would be not like terms here. So you cannot combine, if you are just adding or subtracting, you cannot combine an x squared with an x. So adding is going to be fairly simple. And we will not be using calculators on this part, so this is going to be a little more practice on that mental math, making sure you know those integers. So you're just, if we're adding these, we do have parentheses around them, but there's no number out front to distribute. It would be like there's just a 1 there. So you don't have to rewrite it necessarily, but it would be like there's no parentheses at all for this one. Because if you did distribute those ones, you just get the exact same thing that you started with. So I usually would not write that step, but you could if you wanted. So you're going to group together the things that have the same variable part. So that's going to be a 2x squared and this 9x squared. I'm going to grab, whenever I do the 9x squared, I use the sign in front of that number. So I have a positive 2 and a positive 9, which is going to give me positive 11. And then leave your variable exactly the same. So don't do anything with your exponents. You're not multiplying those together. You're just keeping it the same. This is like if you are adding 2 oranges plus 9 oranges, you have 11 oranges, right? Not 11 oranges squared or something like that. So you just, to add and subtract, you just keep that variable the same. Next, I'd look at my x's. So notice how I'm circling the sign in front of it for both of these. Not the sign behind, or not leaving out the sign altogether, but the sign in front. X doesn't have a coefficient. It doesn't have that number in front of it. What should be there? 1. So if I put these two together, I've got 7x and 1x. Jada, what am I going to get? Very good. And then our last one here, we would be looking at this negative 3 and the negative 4. We can put those together. And so, Vince, when I have negative 3 and negative 4, what am I going to get there? Negative 7, so I have a minus 7. You cannot combine anything else further. It feels like you should be able to put that 11x squared and the 8x together, but you cannot. I remember whenever I learned this, whenever I was in 9th grade, I felt like the x's and the x squared should be able to be put together, and I felt surprised that they could not, but they cannot. Okay. All right, so let's look at some more problems here. We're going to do number 8 together, and I'm going to let you guys try 9 and 10. So, again, all of these are plus signs. There's no number that has to be distributed. So, I'm not going to rewrite it like I did on the last one. I'm just going to go ahead and start grouping. So, I've got a 2x squared here, and then a negative x squared here. So, Laura, what's that going to give me when I put those two together? Just a 1x squared. You can write the 1 in front of the x squared if you want, but you do not have to. Okay? Then I'm going to look for my x's. So, yeah. Negative x and 3x. Caroline, what am I going to get when I put that negative x and that 3x together? Nope. It's going to be, it's like a negative 1 and a positive 3, so negative 1 plus 3 would give you a 2x. And then, Julian, I've got to put my coefficients together. Or not coefficients, constant terms, the ones without x. So if I put those together, I've got 9, negative 4, and 8. What will I get when I put those together?
9, negative 4, 8.
Mm-hmm.
Oh.
What do you get when you put the 9 and the negative 4 together? Positive 5. Right, it's just like doing 9 minus 4. And then 5 plus 8, what do we get, Julian? 13. So plus 13. We okay here? Alright, try 9 and 10 on your own.